Okay, we assume two ramps of equal length. On one, a ball has an average velocity of 40 centimeters d per cycle. On the other, 30 centimeters d per cycle. They're started both from rest at the same instant. The first question then is, how long does it take the first ball to get to the end of the ramp? How long does it take the second ball to get to the end of the ramp? Actually, before that, we ask which ball will get to the end of its ramp first. We'll see how long it takes to get to the end of the ramp. But in each case, the displacement, delta S, is equal to the average velocity times delta t. So on the first ramp, the average velocity, well, in each ramp, the average velocity is going to be delta S over delta t. So the average velocity on the first will be, well, we know it's 40 centimeters d per cycle, and we know that the delta S on the ramp is the length, and let's call delta t1 the time. Okay, on the second ramp, the average velocity is 30 centimeters d per cycle, and that's equal to the length divided by the time the second ball requires to get to the end of the ramp. So that if we solve for delta t1 here, delta t1 is going to be the length, well, and this, let me back up a second. This is something some people had some trouble with on the quiz, so make sure you go back and review this. But if average velocity is length over delta t, well, we could write that this way. Average velocity is delta S over delta t, where delta S would be the length, and delta t would be delta t1 or delta t2, depending on which of the ramps we're talking about. Well, if v bar is delta S over delta t, then the question is, what's delta t? Well, we multiply both sides by delta t to get v bar times delta t equals delta S, and then we have v bar delta t equals delta S, and we divide both sides by v bar in order to get delta t. We end up with delta t is delta S over v bar. I'm going to do another supplemental short video on more detail on this solution, because some people, as I say, didn't quite get the algebra right, and we want to make sure everybody's algebra is up to at least this. Algebra doesn't get too difficult during this course, but we do have to have the basics. Okay, so we then conclude that the time down the first ramp is whatever its length is divided by the 40 centimeters d per cycle, the average velocity, and delta t2 is the length divided by the average velocity on that ramp, 30 centimeters d per cycle. Now, which one is going to be bigger? Length divided by 40 centimeters d per cycle, or length divided by 30 centimeters d per cycle? Well, a larger denominator gives you a smaller result. If you divide by a bigger number, you get a lesser result. And from this, we can conclude that delta t1 is less than delta t2. So the bigger denominator implying the lesser result. This is because the bigger denominator implies the lesser result. Now, this fits with your intuition. Most people would immediately say, well, the one that goes faster is going to get there more quickly. And since the ball on the first ramp has the greater average velocity, we know that it's going to get there more quickly. But this is how you would write it out more rigorously, and you need to develop the ability to do this. More so for the 201 than the 121, but the 121 is going to have to do some of this too. Okay, so one way or another, we conclude that the ball gets to the end of the first ramp before the ball in the first ramp reaches the end, before the ball in the second ramp reaches the end. Now the question of how many pendulum cycles does it take the ball on the first ramp to get to the end? Well, the length of the ramp was given to be 120 centimeters deep. And if we divide the delta S by the average velocity, we're going to get the time interval. So we divide the 120 centimeters d by 40 centimeters d per cycle. That is, every cycle we travel 40 centimeters d. So to travel 120 centimeters d is going to take pretty clearly 3 seconds. Okay? Moving at 30 centimeters d per cycle, it's going to take 4 cycles to move 120 centimeters d. 120 centimeters d divided by 30 centimeters d per cycle gives you 4 cycles. So this one's going to take 3 cycles, this one's going to take 4 cycles. Now here are the calculations. Delta T1 is 120 centimeters d divided by 40 centimeters d per cycle. Now I haven't gone through the details of that calculation. I'll do a supplemental video. But as we see, delta T can be obtained by dividing delta S by V bar. In these cases, it's very clear. We can just reason it out. We don't really need a formula. We don't really need to use algebra. Here's the algebra that we would use. We get 3 cycles and 4 cycles. 3 cycles for the first ball, 4 cycles for the second ball. So the final question is, if the pendulum completes 120 cycles in a minute, then how many seconds is it between the time the first ball reaches the end and the second? Well, the first ball gets to the end in 3 cycles. The second ball gets to the end in 4 cycles. There's a 1 cycle difference in the time. If there are 120 cycles per minute, that means there are 2 cycles per second, so that 1 cycle difference is half a second. So the reasoning is fairly straightforward. The difference in the times is 4 cycles minus 3 cycles, which is 1 cycle, and at 120 cycles per minute, a cycle takes half a second.